We've been doing some work with factoring methods to help us factor polynomials. And now in this video, we're going to use those new skills to help us solve polynomial equations. So the first thing I want to introduce you to is the quadratic equation in standard form. So we know what a quadratic polynomial is. That's a polynomial of degree 2 where you have the x squared as your highest power. And we've seen this form before, ax squared plus bx plus c, and now we're going to set that equal to 0, and we call that a quadratic equation in standard form. And in this video, we're going to be solving these types of equations using our factoring to help us. Now, I do want to introduce you to this property, zero product property. We're going to make good use of that. And what that property really says is that if you have quantities that multiply together to give an answer of 0, then what has to be true is that at least one of the factors or one of the quantities must be equal to 0. So in other words, the only way to multiply numbers together and get a 0 answer is if one or more of the numbers started out being 0. So we're going to use that in this video to help us solve equations. Okay, and then finally, we have here some steps for how to solve polynomial equations by using factoring. Here they are. Let's go over them quickly. We're going to set the equation equal to 0. We're going to factor the polynomial completely. And then we're going to use the zero product property to help us solve. So I want to show you with an example. So in example 1, notice it says solve. Those are our instructions. And notice that in example 1, we do have an equation. I want to show you that that's different to what we've been working on our past videos. Okay, when looking for one of our past problems, notice up till now, you will have seen problems like this where it says factor. And notice that we have a polynomial, but it's not an equation. Do you see that? It's not set equal to anything. It is just terms. It's a polynomial, and the directions tell you to factor. So now in this new section, you're going to be asked to solve. So that means solve for the x that's going to make the equation true. And you need to keep these two types of problems separate in your mind. Otherwise, you will make the wrong choice. So very important here. So this is the old type of problem. These were expressions. There's no equal to anything, and you're just being asked to factor and completely and stop. Now let's look at the new equations that we're going to be dealing with in this particular video. Now look here. Here we have an equation. Do you see the equal sign? And look at the directions. It says to solve. Different. It's different. I just want you to point that out right now. Okay, so here's what we're going to do. On the left-hand side of the equation, notice that we've already got this in factored form. Isn't that nice? They've done this first step for us. And so now we have these two quantities. We have the quantity x and we have the quantity x minus 7, and they're being multiplied together to equal 0. So we just talked about this zero product property that told us, well, the only way that you can have these two quantities multiply together to equal 0 is if one or both quantities started out as 0. So we're going to use that fact to help us solve for x, because we're going to now rewrite two equations. The first equation is where x, that first quantity, that's equal to 0. Or the second equation is, well, maybe the x minus 7 is the quantity that's equal to 0. And now let's solve for x in both of these equations. So of course, the one on the left, it's already solved. X can be 0. But then over here on the right, we get that x could be the number 7. So for this original equation, we have found two possible solutions, haven't we? Let's check them. So solution number 1 is x equals 0. 0 times 0 minus 7, does that equal 0? Notice how I'm substituting my solution into the original problem. And of course, 0 times negative 7 is 0, so that checks. And then we have solution number 2, which is our 7. And now when we check that, we get 7 times 7 minus 7. Does that equal 0? And of course it does, because we have a 0 here. So that means that our equation has two solutions that work. And sometimes you'll see them put into these nice little roster forms for sets, right? Notice I'm not going to use a parentheses because that would mean an ordered pair. But I can use these curly brackets, right? And that means I've got these two solutions. 0 or 7 are two solutions to the original equation. So let's take those skills and go look at number 2, which is a little bit different. Okay, so in equation number 2, once again, we do have an equation because we have the equal sign. We have been asked to solve. Okay, now equation number 2 is not factored for us, right? So we are going to have to rewrite the equation first. So the very first step when you're solving polynomial equations by factoring is to rewrite the polynomial equation in standard form. And what does that basically mean? That basically means get a 0 on one side of the equation. That's your first goal. So that means here that we're going to add that 5m over with that m squared. Okay, so step 1, standard form, get a 0 on one side of the equation. Okay, so here it is. M squared plus 5m equals 0. So now we've got the equation in standard form. Step number 2 is factor completely. Factor. This is where you're going to use your factoring skills that you've been working on for the last few sections. So this particular binomial that we have here, right, because it's got 2 terms, did you notice a GCF? Yep, the m. The m is a GCF. Okay, so again, remember, we are using all of those skills that we've been practicing in the last few videos to factor this equation completely. So that means a GCF of m. So m times m plus 5, and then of course equals 0. We're just rewriting that. Okay, so now we're ready to use our zero product property, and that means that we're going to set those 2 quantities, each of them to 0, and solve for m. So we get m equals 0 or m plus 5 equals 0. And we solve, and here we get m equals -5. And so our solution is 0 or -5, which are easily checked, right? So let's check. Okay, the 0 equals 0. So I can check that just by sight. Let's check that -5. Just back into the original. So we have -5 squared. Notice how I put that parentheses. That's important, okay? And so over here I get -5 times -5 is 25, and which equals 25. So notice that that's checked. So our solution, these 2 numbers, m could be 0 or m can be -5. Both of those work into our original problem. So did you notice what we did? Step number 1, rewrite the equation in standard form, get that 0 on one side. Step number 2, factor completely, and then take each of your factors and set them equal to 0 from the zero product property and solve for your variable. And checking is a good idea. So let's go to the next problem. Okay, in this next problem, we have an equation again. We are being asked to solve. We need to rewrite it in standard form. Good idea when you're rewriting in standard form that the leading coefficient, that leading power, the highest power, in this case the p squared, let's try to make sure that coefficient is positive. So in this case, I would recommend that we subtract the 20p and add the 99 and bring it over to the left-hand side of the equation, so that our p squared coefficient is positive. So that's our first step. So let's do that. Okay, so here it is. P squared minus 20p plus 99 equals 0. And then step number 2 will be factor. Do we recognize this? GCF is 1. So it's a trinomial, 3 terms, but it's a trinomial with a leading coefficient of 1, which means that we're going to look for 2 numbers that multiply to a positive 99 add up to a negative 20. Multiply to a positive 99, and they have to add up to a negative 20. And so you probably know that those are 2 negatives, right? To multiply to a positive and add up to a negative. Yep, 11 and 9, you're right. So 11 and 9, those multiply to a positive 99 and add up to a negative 20. Now we're going to use our zero product property and write those 2 new equations. One that says p minus 11 equals 0, or p minus 9 equals 0, which means p equals 11 here, or p equals 9. Awesome. We get those 2 answers, and then let's check one of them. Yeah. Okay, let's check the 9. How about that? 9 squared, does that equal 20 times 9 minus 99? Let's see. We get 81 over here. And then here we get 180, and 180 minus 99 is 81, so that checks. So our solutions, there's 2 of them, right? There's the 9 and there's the 11. Okay, so you're starting to get the idea? Let's look at 4. Okay, so number 4 is in standard form already. Did you notice? They did that first step for us. We've got a set equal to 0, so that's fine. So we're ready to factor, aren't we? It's a trinomial. It's not quadratic, though. GCF of y. All right, so let's factor out the y, and we get y squared minus 9y minus 36, and that's going to equal 0. Wonderful. Okay, so now we've got the trinomial. It's a trinomial that's fairly easy for us, right? Because the leading coefficient is 1 y squared. So we're once again looking for two numbers that multiply to a negative 36, add up to a negative 9. Negative 12 and positive 3 is right. Okay, so now notice how this time we have three factors that multiply to 0. So guess what? We are going to have to solve three equations. The first one is the GCF y could be 0, or y minus 12 could be 0, or y plus 3 could be 0. Okay, so here we get y equals 12, or here we get y equals negative 3. So we did get three answers, 0, negative 3, and 12. We could check any of these, and I'm going to leave the check now to you. But I do want to tell you something here. Interesting thing about polynomials. So see how the original polynomial had degree 3, right? It was a y cubed. So we would be expecting three answers. We would be expecting three answers because of the degree. Okay, just a little thought.